All right, algebra, we got two more examples on dividing polynomials. We're talking about polynomial long division for most of these, to be specific. So our first one, we got 2x squared plus 3x minus 40. That trinomial is being divided by the binomial x plus 5. So I'm going to write this out as a long division problem. And that's divided by x plus 5. And I start with, how many times does x go into 2x squared? So this is actually similar to the last example. X times what gives me 2x squared? Well, I would need to multiply by 2. And remember, we're going to put it not over the first term, but the next term, because we're putting x plus 5 into 2x squared plus 3x. So x times 2x is what we want, because 2 times 1 is 2, x times x would give me x squared. And then what we do is we take this 2x, we multiply it by this binomial here. 2x times x is 2x squared. We should be getting the same term there because we want them to cancel. 2x times 5, that is 10x, and we subtract. When you subtract, they should always be like terms. If they're not, you messed up somewhere. Like if you have 3x minus 5x squared, you messed up because they should be like terms. They should have the same variable raised to the same exponent. So 2x squared minus 2x squared cancels. 3x minus 10x, that is negative 7x. And I'm going to bring down the negative 40, just like you do long division. So now I'm going to do x into negative 7x. X times negative 7 would give me negative 7x. I take the negative 7, I multiply it by each term. Negative 7 times x is negative 7x. Negative 7 times 5 is negative 35. I'm subtracting, just like you do in long division. So negative 7x minus negative 7x cancels. Negative 40 minus negative 35, that'd be negative 40 plus 35, which would be negative 5. We've got a remainder. So what happens when you've got a remainder is, since this is minus 5, we're going to do minus, and then we take this 5 and we put it over x plus 5. You put it over whatever you were dividing by. And that is our answer. So 2x minus 7 minus 5 over x plus 5. All right, let's look at our second one here. So this one's a little different in that the terms are not in standard form. They're not the largest exponent descending. That's a problem. We need to rewrite this so that it is the largest exponent. So 7x minus 20 plus 6x squared. I want that to be 6x squared plus 7x minus 20. Same thing with what I'm dividing by. Instead of 5 plus 2x, I want this to be 2x plus 5. And now we'll be able to do that long division. So I'm going to take the 6x squared plus 7x minus 20 and divide that by 2x plus 5. So I'm going to start with, how many times does 2x go into 6x squared? Well, 2 times 3 gives me 6. X times x gives me x squared. So 3 times 2 is 6. X times x, x squared. So they're going to cancel. 3x times 5, that's 15x. I'm going to subtract, just like you do in long division. 7x minus 15x is negative 8x. I bring down my next term, the negative 20. So I'm going to say, all right, how many times does 2x go into 8x? My marker's like dying on me here. That would be, or 2x into negative 8x, that would be negative 4. Negative 4 times 2x is negative 8x. Negative 4 times 5 is negative 20. So I subtract those. Negative 8x minus negative 8x cancels. Negative 20 minus negative 20 also cancels. I have no remainder here. So my answer is just 3x minus 4. All right, those are two more. I got one more video coming.